Doing good. How are you?
I'm doing all right. So when's that Meta interview? It's coming up, huh?
It's tomorrow.
Tomorrow. Okay. So I'm
Yeah,
the final boss, if you will, to see how we do here. How are you feeling about it?
I'm a bit nervous, to be honest.
How'd things go with? I think you had Joe and Paul already, right? How'd those sessions go?
Uh, they went well. So, most importantly, I got some practice and good feedback. So, I think, yeah, I could include them into my preparation. So, yeah.
Perfect. Awesome. Um, well, we can jump right in. I want to ask first, are there any questions I can help answer? Of course, I was at Meta for 5 years. I was a staff engineer there, asked tons of these system design interviews, so know what the process is like. Is there anything I can alleviate going into tomorrow? Otherwise, we can go into the mock.
Okay, yeah. So, you said you have some experience with interviewing at Meta.
Yeah,
I think one question that was bugging my mind when I looked. So, there are two things: product design interview and system design interview. So,
correct.
what's the difference? If you can tell me.
Yeah, so it sounds like you selected with your recruiter system design, right?
Yeah.
So the difference is mild. The reality is on the ground. The reality on the ground is that a lot of interviewers don't actually even know the distinction. So the distinction as they present it is that in the product architecture interview, you're going to focus a little bit more on APIs and on data models and
Okay.
on designing a user-facing application. And so, for what it's worth, this is something that oftentimes you'll do in a system design interview. And I think the more important distinction is that there's two types of system design interviews. There's what you can call, forget Meta's terminology, but you can call a product design interview. And this is a user facing application. Design Uber, design Ticketmaster, design any of these that you know, right? A chat application. And the
Right.
second one is like these infra design questions. Design a rate limiter, right? Design top K, design a message queue, things like this.
Yeah.
So in a product design interview, you're guaranteed to get a question from that product design bucket.
Okay.
But in a system design interview, it's, call it 50-50, maybe
Okay.
60-40 on the product side, but like you could get one of those back end questions purely. Now
Okay.
at your level, at mid level, it's still more likely that you're going to get one of those product style questions.
Okay.
But you shouldn't be shocked if you get asked to, for example, design memcache on a single server is a very popular question right now. You should
Okay.
actually maybe research that tonight. But
No,
anyway,
actually, yeah. Yeah. Got it.
does that answer your question?
Yeah. 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 That helps. Thank you.
Perfect. Okay. Um, should we get started?
Yeah.
Let's do it. So I'm going to open up that Excalibur whiteboard. You've been here and done that, so you know the process.
Yeah.
And the question that I have for you today, and tell me if it's one you know well, and we can do a different one, but it's asked quite a lot at Meta right now in mid-level system design interviews, and that's design Dropbox.
Yeah. I think I did look at Dropbox question and a couple of solutions to it.
Okay, so you want to do a different one?
Yeah. Probably that would be
Okay.
better. Yeah.
Have you read the answer keys that I've written and posted on Hello Interview?
So the approach to system design.
There's about 5 answer keys that we've published: Ticketmaster, Uber, Tweet Search, Live Comments, and GoPuff. Have you read those?
I think I did read the Ticketmaster one and the approach, but the other questions I haven't looked at.
Okay, so I'll let you choose. Both Uber and Live Comments, which is the comments under a live stream, are two popular questions asked at Meta. Which one do you want to do?
So again, I think I looked at the Uber question a couple of times.
Let's do
From
let's do live comments then.
Yeah, yeah,
So let me kind of set the scene for you there. Of course, you're probably familiar with Facebook and Instagram Live, respectively.
right,
So
right.
your task is there's another team who's responsible for the live stream that is outside of scope. Your scope is the comments that are under that live stream coming in real time. And so that is what your team is responsible for, and thus what you're designing here in the system design interview. So just quickly from a requirement perspective, and you can kind of ask me questions so we can go deeper, but of course, users should see comments on the stream in real time, but they should also be able to scroll up and see past comments. So
Okay,
scroll up and load the past 100, scroll up, load the past 100. You kind of know how that works. So
right.
I'll let you take it from there.
Okay, okay, yeah. Sure. So let me list down the functional requirements for clarity. So So uh, so post a comment. User should be able to post a comment, and so by default, users see probably the latest 10 comments. This number can be anything. So, and also we should be able to fetch the comment history. So, do we want to able to search comments?
Nope, don't worry about it.
Okay. So I think I'll just list down the non-functional requirements we would like our service to have. So should uh, definitely be highly available. Should have as less interruptions as possible. Should be scalable as the users grow, and so yeah, the performance should give a reasonable performance and not degrade. And I would probably so I think we would be like the comments to be durable when you user posts something, it's not lost.
Totally.
Yeah. So I see this can be the requirements. Is this fine, or do you want to add anything or
I
want me
think
to?
I think this is a good list.
Okay. Okay. So I think looking at the problem statement, we do require to operate at scale, should be able to operate at scale for apps like Instagram or YouTube. So probably estimations are not will not point to any different direction. So I'll start with the high level design. Is that fine?
I think that sounds fantastic. Yeah,
Yeah. Uh, or let me just start with the API and data modeling. So
perfect. I think the one thing I'll throw at you in terms of capacity estimations, and I think you're right to forego them here, but the most popular Facebook live stream had 180 million viewers. So
okay.
keep that in mind as your upper bound.
Right. Yeah. Sure. Yeah. I didn't know that. Yeah. That's amazing. So posting a post comment would be one API. So the user should be able to send these are the parameters. So there can be some additional things, maybe the timestamp, but these are the most important ones. So refresh feed, which fetch the latest comments. So this will also send user ID and the token probably for the authorization, but the important one is a video ID. And yeah, fetch history. So it would be again user ID, video ID, and yeah, maybe certain number of comments. Let's say 100 or 1000, could be anything which the user requests. Yeah. So the data modeling. So yeah, the major table that we would have is comments, and so definitely each comment will have a comment ID, which should be the primary key, and it should be associated with the video ID and also the user ID and the comment itself. So yeah, so I think I want to include timestamp. This would help with the ordering of comments of
So
particular user.
definitely.
It's difficult to have a global ordering because the clocks can be different. But I think for a particular user, we should be able to order the comments. Uh, So does this look fine?
Yeah, that looks good for
Uh,
comments for sure.
so definitely there would be the other tables, user table.
Yeah, don't even bother enumerating it. I know it's in a user table, and I know you do
Yeah,
too.
yeah, yeah. So okay, so let me start with a very high level design, and
Sure.
I will go deep into the components later. So we um, we should have two services, one to write and one to read, so that we can scale them independently. So as we are going towards a microservice architecture, I have a gateway. So let's say this is a write comment service, and this one is fetch comments. Yeah. So let's look at the right path quickly. So yeah, I want to discuss. I think the major part I think would be to see what data storage that we would like to use.
Okay.
Uh, I think so. There are not many relations. Of course, there is a video ID, uh, but other than that, there are not many relations that we query every time. So we can probably we don't need a relational schema. We can go with a NoSQL database, and within NoSQL database, I think some sort of eventual consistency should be fine. Uh, if the if the every user does not see the same set of comments and probably seconds, 1 or 2 seconds of delay, that should be okay in our sort of the requirement.
Yeah, I agree.
So we can probably do eventual consistency, or maybe read your own write consistency, so that user will not see their comment disappear even for a short while. So we can use something like a Cassandra database is what comes to my mind. It gives us very high write throughput, and so so one question, whenever we are using something like Cassandra, which is a leaderless replication, would be how do we want to handle write conflicts. So there could be write conflicts, some users sending multiple writes at once and both them going to different replicas. So I think we can have a reasonable uh, so the last write conflict which Cassandra uses by default should be fine if we are using the timestamp that user sent. So uh, so yeah, let me just post database. Yeah, so I think one other thing, uh, yeah, so we would like to partition based on the video ID, so that all comments related to a video go to one particular partition, and we can have a secondary index based on timestamp, so that we can fetch the latest comments quickly. So say say the write service writes to post database, and yeah, so we can discuss how it performs in detail. Let me just come up with the read path. So I think uh, we would see a lot more reads than writes, maybe 100 is to 1 or even high. So
Oh,
maybe
even more than that. Yeah.
yeah, million is to one. There are a large number of users. So so I think we should try to optimize the read path. And so what comes to so we should probably reading most of the time from cache that's in memory and not hit the disk very often. So yeah, so in case the cache has not refreshed and was fallen a lot behind, probably we can fetch database, but this should be a rare operation. So regarding refreshing the cache, I think probably something uh, I find in how the social media apps generate feeds. So whenever there is a post, so then they try to generate the feed and pre-generate the feed and fetch for the users. So probably something like that should be the approach here. So whenever there is a write to database, so we most of the database support streaming of change events. So we can capture all the change events to something like uh, so this can be any message broker, but yeah, so I think because we would like ordering of within a video ID, with a particular video ID, we would like there to be ordering. So probably something like a Kafka, which is durable and also maintains order within partition, would be better. So let's say, so there would be a lot of updates, a lot of comments. So we would like to process them in near real time. So we can have a stream processor, probably something like Flink. So
And what just taking a step back, and you might have said this and I missed it, but what problem are you trying to solve with this setup over here?
yeah, so whenever there is a write, we will try to refresh the cache.
Mm-hmm.
We'll try to the database, and asynchronously we'll try to refresh the cache so that the fetch will happen from the cache.
And why not just write to the cache in real time, the same time as you're writing to the database or upon success? Why have this setup?
Yeah, so let me see if the real time has any issues. So I thought asynchronous processing would be we will be able to handle load better this way. So
But this is making the assumption, and forgive me for interrupting here, but this is making the assumption that Cassandra is going to be able to handle this load fine, but that Redis or Memcache or whatever you've chosen as your cache won't, right?
right, right, yeah, yeah, yeah. Probably I think yeah, I think Redis and Memcache both are very well scalable. Probably we can write directly.
Yeah, if
Yeah,
anything, they can handle it better than Cassandra will be able to, right?
right, right. Yeah, they operate in memory. Yeah. So yeah. So let me. Not sure how can I undo this. Uh,
You can hit just the delete key. So you highlight all that and just delete it. There you go.
yeah. Right. So this would be the high level approach, and also we would like to have a load balancer in front of each service so that we should be able to scale horizontally.
So let's talk a bit about this read path. You're going to
Yeah,
fetch comments. You're going to fetch them from a cache. That's great. You're going to use CDC to make sure that the cache is consistent with what's in your database. Some eventual consistency there. Totally fine within the bounds of your requirements. Now, What's the actual process from the client? I assume the client's polling here. How frequently? Kind of walk me through that.
Right, right, right. Yeah. So I think because we want this to be near real time, probably instead of polling, uh, I think server-side events would be better. Once client opens a connection, and the server would continuously send push the events to the clients. So probably we'll have sorry, this I want this to be a cache. Yeah. So let me see how we want to do it. So I think it should be some kind of event mechanism where the server pushes periodically at least the latest comments. We should not wait for the client to send request. So one thing that we need is the connection information from clients, and yeah, so we definitely have to read this from in memory to be able to handle it faster. So yeah, I think okay, based on this, let's say it's connection info. Yeah, so both can be cache. So this holds the actual data, and this holds the connection information. And also we can probably uh, so this one we can use consistent hashing with the video ID. So comments of each video, again similar to database, go to the same machine. Right. So in a similar fashion, so this can also be a cluster, and we can use consistent hashing with video ID as the partition key, as the hash key. So we'll be able to fetch the information of all users uh, from a single machine. So right. So let me see if we need to read from database at any time. It should not be necessary. So yeah, I think if change data works as expected, this should not be necessary.
So walk me through a full life cycle here.
Yeah,
A user writes a post, follow through each of these arrows, show me how state changes and what's
yeah,
read at each point.
yeah. So let's say user writes a comment, and now it goes to the database, and we find the partition to place it in, and we place all these details with the video ID and the timestamp. So now this generates an change event, and we want to write to Redis. So we have to see, uh, we need to evict probably if the cache is holding more than 30 or 40 comments for a video, we only want it to be latest. So we would like to evict the oldest one. So something like a FIFO eviction policy, and we update the cache with the comment to the video, and now we want to send these to the all the users. So we fetch all the users
So
connect.
first off, for this part, when?
So writing to the cache.
No, for the you're going to fetch all of the users. When?
Right. So once the cache is updated, then we would like to fetch all the user information.
And how are you going to know that the cache was updated?
Oh, sorry. Right. So I think one thing that comes to my mind is Redis can push a message, uh, generate an event whenever the particular video ID comments are updated, and then we'll know how to fetch. Or we can periodically fetch refresh cache for every video. So I think the first approach would be better because some, yeah.
Sorry, I think you were about to say it, but walk me through that first approach. What exactly would be happening in that first approach?
Yeah, so we would like to generate an event where whenever there is an update, and there should be a service which subscribe to the event and knows which video ID uh, has been updated, and then that service should be able to look up the connection information and send out all the latest comments to all the users.
Okay, so go ahead and update your diagram a little bit to reflect that, and then let's talk about that.
Yeah, yeah. So let's say this is subscribe uh, to the event changes, and so this will read the connection information, uh, and it should be able to send back, or let me see if we need a different service or fetch comments can play this role. Yeah, I think I probably don't need a separate service. So so the events,
So, so strictly speaking, what is this arrow?
uh, so the Redis publishes a message, and this should be a subscriber to the message.
Cool.
So and Redis functioning as a message broker. So
So,
in case, yeah,
so this is using Redis's pub sub.
yeah.
So you're publishing a message, and that message, really, this event here is just the comment data, right?
Yeah, it can just be the video ID, or it can
Okay.
also have the comment information from the cache.
Okay, so the video ID, and then fetch comments is going to get that in real time. There's going to be a number of fetch comment instances, of course, and they'll all be consumers. And then
Yeah.
what happens from there?
So now we know that there's an update to a video. So we will like to fetch all the connection information related to the video and push the comment information in real time to the users.
And so let's go deeper on that part. How are you going to do that part? What is the connection information? I understand that you've opened up server side events, these bidirectional, or excuse me, unidirectional connection.
Yeah.
Um, but go into more detail as to what happens there when you fetch from connection information. What are you fetching, and then how do you ultimately push data to the clients?
So uh, the server side events works on, so once the connection is established, the server should be able to send all the messages to the client. So we will have the port address and the host names of the clients,
Hmm.
and we should be able to push the events to the client.
So that all makes sense. Now, what if I told you that you have a slight problem in that you're going to have a lot of instances? Well, maybe let's talk about it this way. Even for one video, we talked about that there could
Yeah,
be almost 200 million connections,
right, right,
right? So for your awareness, a single box, a single instance obviously can't hold that many outgoing connections by SSE.
right,
So you're
right,
going to have a lot of different boxes, ultimately all over the world. You're going to have tens of thousands, if not hundreds of thousands of instances.
right,
And they're all going to have some up to a million outgoing SSE connections. So how do you know which box to tell there's a new comment? Does that question make sense?
right, right. Yeah,
And when I say box, of course, I just mean server, just
yeah,
shorthand.
yeah. Right. So I think we should not send events for every video to all the servers, because it's a lot of wastage. So yeah, we only want to send, want to make few servers responsible for certain videos. So right. So I think uh, w- yeah. So and the servers could be changing, and so I think one thing that comes to my mind, even the servers could be arranged in a ring like consistent hashing, and each server would be responsible for a range of video IDs, range of hash of video IDs, and we let me. So we need to externalize the information about the consistent hashing. So because services we would like them to be stateless, so we can use a coordination service for this purpose. So I think this is one approach that we can take. So we'll know which servers to push to.
So where does the coordination service come in? When is it called? And
Yeah. So instead of sending the events directly to the all the service servers, we will look up, we'll look up in the coordination service which service are responsible for this video ID, and then we'll forward the request to only those servers.
how does Redis communicate with the coordination server? Is it still PubSub there?
Uh, no, I don't think coordination service can be a subscriber. We'll probably need a different service. So let me modify this diagram. So this will the fetch information and forward the request.
And so now, what's this arrow? Is this arrow still PubSub?
Yeah, yeah,
Okay. So you have PubSub with a single subscriber, or maybe multiple instances, but only to the
yeah,
extent where scale is necessary.
yeah.
It's going to ask the coordination server for video ID 123, which servers do I send this to?
Yeah.
And then how does this guy communicate with each of those servers respectively? It got back an IP address or an internal IP address within the VPN, whatever it may be. How does it respond?
So uh, so this can be over HTTP. You can make an API call to all the services,
Mm-hmm.
or if it is within a data center, I think something like gRPC or protocol buffers could be faster, but I think it could be either of those.
Got it. Okay, so then it went to the server. Now the server has some new video ID, and presumably maybe you sent it to N servers. all of whom have users who are connected via a live video ID. Now you have some kind of difficult coordination between this guy and this guy and all of these when they come up and go down. So maybe think about that for a moment. Walk me through what problems you see and if there are any solutions.
So, uh, so one thing is how do you update the connection information as the clients as the clients are joining in and leaving. So I think I see that that's one thing that we need to think of. And so so the coordination service, I think this has to be we need a strong consistency from this uh, probably. So yeah, it's not an issue. So I think managing this user information as the users are changing over time is one thing that we should think of. And let me see if during this read path can anything change. So this has server information responsible for video ID. So the clients. Okay. So yeah, I think one other thing that I think can think of is if certain machine has gone down, which was responsible for a particular video ID,
Mm-hmm.
and so it was only one event, and now these services do not know let's say let's call this probably just a messaging service. So this does not know if the message is actually delivered or not. So an instance of server can just go down. Of course, so there will be rebalancing of keys, but we would probably like to see that the message is delivered even in such cases. So two things: when the users are changing, and also the new machines could join in and go down. So these two things probably we'll like to handle. So first, I'll just try to see how I can handle users changing over time. So yeah, so probably we would like to keep our connection information up to date. So uh, I think we would need to. Uh, I would like to add particular use case when the user wants to join the stream. So that's one thing that we need to handle as well. So, so yeah, so let's say we have another service which is responsible for keeping the connection information up to date. So the user requests to join, user just joins the live stream. So the request would come to the service, and it will update this cache with the connection information, and this arrow would be just read. So while we are updating, we probably okay, it's not a concurrent update. So I think it's fine. If the connection information is seen with a little bit of lag, that's fine. So we need not put a log while we are writing. So if the user receives probably a few seconds delay or few milliseconds delay, that's fine. So this need not be like an atomic write and transaction. So and
So let me stop you here. This is 36 minutes, which is in line with what you're going to get in your meta interview. You're going to get 35 minutes. Potentially, they'll let you go a minute or two over to overlap into questions. But this will be about faithful to the time that you'll get in the interview. So let me first, before I go into some of my thoughts and feedback, let me hear from you. How are you feeling? How do you think it went? What's your self-assessment?
Yeah, I think few parts I was able to think of the potential problems, but I think in certain parts I was vague. Uh, Probably, yeah. I think it's something I haven't looked at before. So I have looked at the streaming problems, but they are a little bit different from this one. So I would say I'm a little bit just about satisfied with myself, but not not like really elated. Yeah.
That's fair. Well, I think you should be proud of yourself. This was good for a mid-level interview in particular. This was particularly good. I would hire for what it's worth. I would hire with average confidence at mid-level, and so there's a lot here that could be improved. There's many aspects, in fact, that were wrong, strictly wrong as well. And you and I'll have a chance to talk about that.
Okay.
But you breeze through the high level design, the basics, and a lot of the places where you're making mistakes are at a level of depth that's more required of a senior
Okay.
candidate than a mid level candidate. And so I can completely forgive those mistakes. And in fact, you showed depth that exceeds the average successful mid level candidate. So kudos. Um, at a high level, and I'll go through your interview in detail here with you in just a moment, but just at a high level, well, while it's a higher, the failure state for you in your interview tomorrow appears rather clear to me. And that failure state is that you get caught in a situation where you over engineer.
Okay.
So I can tell that you've studied, you've practiced a lot, you've seen a lot of these questions, you know a lot of information, and that's evident and that's fantastic. But what you now need to do, and this really comes frankly from experience, but you'll be able to derive this, I think, hopefully from this advice tomorrow. And that's remain simple. Anytime you add a new component, ask yourself, is this needed? Every
Okay.
time you add a new service, is this needed or can this be handled by an existing service? What is my strong justification for adding something new here? And you made some good justifications that shows you know what you're talking about as it pertains to like the reading and the writing service being separate because they need to scale independently. Yeah. In general, if you're going to separate out compute, there's largely one of two strong justifications. No, the third being the team consideration, but let's forego that for a moment, right? Like ease of maintenance. So the two that really matter here are: do these two services need to scale independently? Great, you kind of articulated that well in one case. And then the second is along the substantiveness of the compute. Like, is there something that's highly independent and computationally expensive? If so, maybe it should be its own server as opposed to coupling it with another computationally expensive task, right? This could be reasonable. So those are sort of the two things to ask yourself. I think they seemed clear based on your justifications, but ultimately your design, we'll talk about it in detail now, had aspects of over engineering. We talked about this a lot, and aspects of over modularization. And I think
Okay.
that's going to be your failure state for tomorrow. And I think it's unlikely. I'm confident actually you're going to pass and do well tomorrow. But that's the one thing I want you to be hyper aware of in your interview tomorrow. Does that make sense and resonate?
Yeah. Yeah.
Perfect. Okay, let's talk about your interview then in detail. And of course, I'll also paste in an answer key here at the end. I actually have a detailed answer key on this one that I encourage you to read directly after this
Sure.
interview as well, or when you have time. But let's start with the functional requirements. Perfect, no issues, great. You got the top three. These are the most important ones. I kind of talked through to some extent what they should be anyway, but all good. Let's move past that. Non-functional, this is fine. This actually ends up being largely correct for this problem, potentially out of coincidence. But what I want to encourage you against is like a lot of candidates have a tendency to just throw down these illies here. So kind of blanket like availability, scalability, consistency, durability, whatever. And it's like, this is okay, but it's not particularly interesting. So the question that you're asking yourself here, of course, is what makes this system challenging? What makes it unique? And there's a couple of questions that you should kind of make sure that you always cover. And for what it's worth, you covered these largely throughout the totality of the interview, but you can be explicit here. So the first, of course, is CAP theorem. You largely mentioned it by prioritizing availability, but I think that you could do a little better here by contrasting it with consistency in the context of CAP theorem.
Right.
So why are we choosing availability over consistency explicitly?
Yeah.
And then the next question to ask yourself is read to write ratio. You ended up kind of coming to this later in the interview, but this has significant consequences on your design. Read is much greater than write. And as a result, we have this whole kind of complex system down here in order to handle the broadcasting of writes. So that's something that's kind of important to note as soon as possible. And then the third is what I refer to as that query access pattern. This is, what's the frequency, irregularity of how your site is being used. And so in your case, this is those maximum and minimum bounds, particularly that maximum. So like that good question to ask is how many concurrent users should I need to support? And that's going to have direct consequences on your design, particularly scaling up this read component. So by and large, this was good enough. Some tips to make this even stronger. API is all good. I have no concerns here with your API. The one thing, actually, let me correct that. Your API is largely good, especially as a mid-level candidate. I do suggest that you be a bit more explicit. The name kind of implies it here, but be explicit that you're using REST, this is POST, this is GET, whatever. You might as well just write those. Don't open yourself up to the question. User ID, I think you know this and you even alluded to it, but be careful here. By passing user ID into the request, it's easy for me to think that this is a security vulnerability. If you're not explicit that this is by way of the session token or JWT or something otherwise in your headers. Right. So timestamps, user IDs, things like this, be careful and make it explicit that they're not part of the request body or the request query parameters. Okay. When it comes to your fetch history, if we had more time, this is a place I would have dug deeper. Of course, as it pertains to pagination, this would not have been sufficient. 100 is great, but starting from where? So there's a handful of ways to handle pagination. Pagination is actually interesting for this question because of the dynamic nature. You can't just choose some N to move back from because of the real-time nature. So you probably need a cursor where that cursor is the last comment that you read, and you're going to move up from there. And then we would have an interesting conversation about your indexing in order to make that as quick as possible and potentially caching. So that's a deep dive that we could have had. Particularly, we would have made sure that we'd done that in a senior interview, but I just want you to be aware of that. I'm going to continue going through, but at any time, interrupt me if you have questions. I want to make sure I'm not just talking at you. Yeah. Data model is good, easy for this problem, so no worries whatsoever. Okay, now some high-level things in your design before I paste in an answer key and we really get down and dirty on the content. While it was relatively strong, I think there's room for improvement in how explicit you are in a couple of places. And you heard me asking these throughout the interview. The first is that there were significant abstractions that you provided by way of your arrows in particular. So it's not always obvious, like how is this server connecting to this server? Okay. And by just drawing an arrow and saying it's getting here, well, in some contexts, like, pub sub is incredibly important. Likewise, like if how are you actually doing this one? Is this that you have a webhook set up here and you're listening via REST, whatever it may be, but being explicit there is important. We can call this the how. And so the second thing, similarly along the lines of the how, is being a bit more explicit about how data flows through your system and how state is changing. So you heard me ask this, I think, twice, which is like, okay, a user just wrote a comment. What happens? And so it's easy to kind of get caught in the abstraction of here's boxes, here's arrows, here. You're talking to me, all largely accurate, but it's not as explicit as saying a user just made a post request for a new comment with comment data. It comes into my system. Of course, my load balancer sends us the correct comment service here. All this comment service does is writes to Cassandra. It writes this data. And oftentimes I like to even put my data model right next to my database because it might evolve whenever. This triggers change data capture, which hits my cache. My cache updates the cache as well as puts that on an event stream, which is my pub sub. You see where I'm going with this. You ended up doing it after my prompting, but you can be a little bit more proactive in how explicit you are. I think that will help. Let me pause here for a moment before we talk about now the actual content of the interview. Does this feedback resonate? Does it make sense? Do you have any questions?
Yeah. So definitely, I think uh, so. I think even Paul, the first interview, I had similar lines of feedback. So he had asked some questions, and I could answer him with some details. This is on similar lines, so I think yeah, definitely this is helpful.
Awesome. Fantastic to hear. Good to hear some consistency too. So I'm going to paste under an answer key below yours. Of course, there's no strictly right answer here, but let's take a look at it. Can you see it down there?
Yeah.
So let me kind of talk about and contrast this with yours a little bit. So let's talk about what happens when a user posts a comment. A user posts a comment, it hits our comment management service. This comment management service handles my writes, and it is responsible for doing two things. The first thing is that it writes to my persistent storage. Cassandra's a fine choice here, doesn't matter. It's going to write to my persistent storage. And then upon successful confirmation there, it's going to publish this to a Redis pub sub directly.
Okay.
And so we'll come back to your design here in a second and talk about where you have some redundancy and maybe some over engineering. But I'm going to publish to PubSub directly. And the important thing here is that PubSub is partitioned itself by at least a hash of video ID. So it's not strictly speaking a topic per video, but you get the point here. So we're partitioned in this way. And then you have all of these real-time messaging services. And these are the things that are responsible for subscribing to the right topic. We'll go into more detail about that in a second, right? But it makes sure that it subscribes to the right topic. And then it forwards that message over SSC, as you pointed out, which was fantastic, great technical excellence, over to the commenter client. And so the way where the nuance is here is that each of these boxes themselves can have in memory, and it's actually smarter for them to be in memory. They can just have a mapping of live video 1, or video 1 to SSC connection 1, SSC connection 2, whatever. And these connections, these are the in-memory pointers, right? So when you then know, based on the keys that are here, which topics you need to be subscribed to. So this real-time messaging service knows that it needs to subscribe to those two topics, video 1 and video 2 respectively. And then anytime that there's a new video, it's obviously just going to then call SSC connection 1.send with that new comment. Easy, right? So that's what's going to happen. And now this is nice because I don't run into the consistency problems that you had of trying to manage this in two places in a distributed fashion. And I don't need them to be distributed. Because what's going to happen if one of these boxes goes down? Well, that user is going to lose their connection. Their client is going to know they lost their connection, and they're going to reconnect. And what happens when you reconnect? Where you're going to have a layer 7 load balancer here that's going to use the live video ID. So you'll have live video ID in the header or something. And that layer 7 load balancer will then, using consistent hashing, connect you to the server that co-locates you with other viewers. And so if one server goes down, that's fine. All those viewers are going to reconnect. We're going to connect you to the next server. And that next server then is just going to update its own map. Oh, here came all these people looking for video 3. All good. I have all of them now. And upon that reconnection, we're also going to trigger, getting past comments just via GET request to make sure that we didn't miss anything, whatever. And then now you're back good and you're rolling and you're rumbling.
Okay. So here, I think, I got it. So when the client requests a connection, that's how a server would know that I need to maintain this information. Is that right? Okay.
Exactly. So upon connection, in that request, in the header, it says which live video ID it's subscribed to. And so the real-time messaging service got a new connection, and it says, oh, I just got a connection from SSE connection 200, and he's subscribed to video 1. Let me update my in-memory mapping and make sure that if I'm not already subscribed to that topic, let me make sure I subscribe to that topic.
Got it. Okay.
Makes sense? So fairly elegant in that way.
So how would the real-time messaging service would determine the topic that it needs to subscribe to?
Based on the keys that are in its internal mapping.
Okay.
So in this case, this one needs to subscribe to video 1, video 2, and video 3.
Okay. So that would be the topic. Got it. Yeah.
Yeah. And so the topics themselves might be a bucket of video 1 through video 200, right?
Yeah,
But
yeah.
using these keys, you can derive which topic you need to subscribe to.
Got it. Got it. Yeah.
And then as users disconnect, these will drop out. And if your value list is empty, you can drop the key and you can unsubscribe from V1, right?
Right. Right.
Easy. So this is how, a decent answer to this problem. Now looking back at your design, a couple things. Let's start here. CDC here isn't necessarily incorrect, but many senior engineers, and including myself, I feel fairly strongly about this, would argue that this is bad here. And the argument would be that CDC oftentimes is used most appropriately in an asynchronous context. So if something's going to change in your database, and then as a result of that change, you need to send an email to somebody, CDC is great. Kind of make a change to your database and then don't worry about things that happen asynchronously. In the context of synchronous changes, this actually creates a pretty annoying disconnect.
Yeah.
Such that from a code readability perspective, somebody's reading the code here and they say, okay, a new message comes in. All we do is write to the database. Well, how does it get to everybody else? And they have to go look somewhere else in some code base to see that there's CDC set up on the data. Like you can see why that would kind of suck, right?
Yeah.
So it makes more sense to instead just do this, wait for a confirmation, and then put it on the pub sub directly. And then this Redis cache is an unnecessary pass through here. You ended up actually not even using it, right? You wrote to it and then immediately put it on the pub sub and then consumed it and then went from there. So a cache isn't a bad idea here. But you can have a cache up here alongside your database, and the cache should be used for pagination. So up and you request the next, say, 100 comments, we actually load.
Yeah.
Pull up again, it's going to be a really fast load. Go ahead.
Yeah. I think I lost your voice briefly there. Yeah.
Okay. Should I say that part over again?
Just the pagination one, I think the last 10 seconds.
Okay.
But I can look up the solution. I get it. Yeah.
Okay, cool. So you can read that one on your own time then. But you can see now contrasting the two designs where there's some additional components, some over engineering. And like I said, that's the place where I want you to be really careful going into your interview. Okay, let me pause. Questions? Again, does the feedback make sense? Does the answer key kind of make sense here?
Yes. Yeah. So definitely. So I think one reason I stumble at few places. I don't have any real-time experience with something like server-side events.
Yeah.
So my knowledge is mostly theoretical. So that could be one reason, but I do see that it can be much more simple. So yeah, definitely this is helpful.
And that's exactly why this is still a hire for me, because a lot of the things that we're talking about are at the depth, like I said, of a senior engineer. And at the depth of a mid-level engineer, you covered all your bases. And then again, I'll say it now for the third time, just to make sure it really sticks. Just be careful tomorrow, because you're going to nail it from a mid-level. And the only way you can kill yourself is by then overdoing it when you get into the depth. And just make sure you're careful.
Yeah. Thank you. Definitely.
Cool. I'll link this answer key. I think you know where to find them, but I'll link the write-up in your written feedback as well. Are there any other questions I can help answer? Anything I can help with?
No, so I think just one thing which I was thinking. So I said I would use Cassandra, and your answer mentions Dynamo, which are very similar. But I think one thing, Cassandra does not allow us to define our own conflict resolution. So would that be a negative here to use Cassandra?
No, I don't think so. I think Cassandra's a fine choice. And the justification of the fact that Cassandra sure can, in theory, handle higher write loads than DynamoDB, maybe something that it could even be debated, but it's a fine choice. And actually, your technical excellence there was brilliant. The depth of understanding of choosing Cassandra, understanding its drawbacks, understanding how you would handle that conflict resolution with the timestamps, all great. Obviously, you'd calculate those timestamps. You'd be careful to either validate them server side or
Yeah.
But yeah, I thought that was totally fine. In fact, I thought that it was more than fine. I thought that it was great.
Okay. Yeah.
Awesome. Well, I'll get started on your written feedback. I'm glad to hear you had a good experience, and thanks for sharing some of the feedback of ways we can improve too. And please let me know how your interview goes. We're invested. I want to tell Joe and Paul that you got hired too, and that's exciting for us when we hear that things go well. So please follow up.
Yeah. Thank you very much. Thanks for your wishes. Yeah.
All right. Kill it tomorrow. Good luck.
Thank you.